Assalamualaikum and hi, my name is Muhammad dan Iezzwan bin Ahmad FAIRUS. In this video, I would like to present about introduction of our project. The increase in population and subsequent urbanization in the last few decades has often resulted in construction of highway on soft and problematic soil. Stabilization of problematic soil typically include enhancement of soil property by addition of admixture. Among the ground improvement technique currently used in civil engineering, with success in practice is the chemical stabilization, where the natural soil is mechanically mixed in situ with binder. This technique has given good result when applied to soft soil nowadays, rapidly growing and widely used in the construction of roads around the world by mixing chemical with clay soil to improve their workability, strength, stiffness, swelling characteristic, and bearing capacity. Additives such as granulate blast furnace slag, fly ash, gypsum and silica dust may be used especially for the improvement of soft soil with high water content or organic soil. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is FAUZUL MUBARAK bin Ahmad FADHIL. So today I will explain the subtopic of literature review that consists of chemical stabilizers and fly ash. So the first one is chemical stabilizer. It relies on pozzolanic and cationic exchange reactions to modify and stabilize soil. Pozzolanic reactions occur when aluminous and siliceous materials react with calcium hydroxide chemically to form cement compounds or gels at normal temperatures. From the picture above, you can see the principal chemical reactions and subsequent products formed in soil by different binder types. Chemical contaminants like lime can reduce the swelling potential, the liquid limit, the plasticity index, and the maximum dry density of the soil, and increase the compressibility and workability of substrate soils. Therefore, lime treated soil is the permit to be melt for 1 to 4 days. Which helps to establish a consistent or homogeneous mixture. Lime stabilization can be a commonly used method of chemically turning unstable soils into structurally sound building foundations. It also improves soil engineering properties by improving strength, improve crack resistance, improve durable properties, decrease swelling, and resistance to damaging effects of moisture. The most significant improvements in these properties are seen in moderate to highly plastic clays. For the second one is fly ash. It has been widely used in several programs to improve soil strength characteristics. It can be used to stabilize base or substrate, to stabilize the backfill, to reduce lateral pressure, and to improve the stability of the slope. The primary reason for the use of fly ash in soil stabilization applications is to improve soil compressive and shear strength. The compressive strength of the soil treated with fly ash depends on the in situ properties of the soil, the moisture content at compaction time, and the additional ratio of the fly ash. The plasticity of soils treated with Class C or other high calcium fly ash is affected by the types of clay minerals present in the soil and their absorbed water. In some applications, soils containing more than 10% sulfate have been prone to excessive swelling. Organic soils are also difficult to stabilize by using fly ash. From the picture above, you can see the compaction of fly ash stabilized soil. And next we go to the methodology. The California bearing ratio CBR value is used as an index of soil strength and capacity. This importance is commonly used and implemented in the construction of the foundation and sub-base material for the pavement. Lime and fly ash stabilized soils are often used for the construction of these pavement layers as well as for embankments. The CBR research equipment is a cylindrical metal mold with a volume of 0.002124 cm, a sample extruder, a 4.5 kg rammer, a measuring cylinder, a sample tray, and a California bearing ratio test unit. Method 5.1.3.3 Method 1 of PS 1377 was used. The mold was assembled with a base plate and a collar attached to the mold. 4 kilograms of soil sample were weighed and the volume of water was calculated as 100% of the soil sample at the maximum dry soil density. The soil was then compacted into the mold with a collar attached to it in 5 layers using a 4.5 kg rammer. The mold containing the specimen with the base plate in position but top face exposed was placed on the lower plate of the testing machine. Readings of the force were taken at intervals of penetration of 0.25 mm to a total penetration not exceeding 7.5 mm. The base plate was removed from the lower end of the mold and attached to the upper end. The mold and the contents were reversed. The test procedure described above was then repeated on the other end of the specimen. The entire process described above was performed with lime and wood ash added to the soil sample in 2, 4, 6, 8 and 10%. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris HAZWAN bin Muhammad ROSDI. So for this group, I will explain to you about result and discussion and conclusion and recommendation. So for result and discussion, as in table 1, it was observed that the wood ash stabilized sample had the highest MBD of 1790 at 2% of the additive, whereas a maximum OMC of 18.2% was observed at 6% of the stabilization. So on the basis of table 1 and 2, the highest MDD of 1670 kg occur in the limit lime stabilized sample at 2% and 4% of the additive. So while the OMC maximum of 19.5% was stabilized at 10%. From figure 4.1, the MDD at 100% unstabilized sample was found to be 15% at the OMC of 1820 kg. The result from the table 3 shows value of the unsoaked CBR for sample stabilized with lime and wood ash indicate that the highest CBR of 110.73% for lime and 92.26% for wood ash was observed at 6% for both lime and wood ash. As for conclusion and recommendation, we found that numerous field and laboratory studies were conducted to evaluate the improvement of geotechnical properties by lime and wood ash. Several lime and wood ash contents and methodologies were used for this purpose. The mechanism of treatment comprised hydration, cation extension, pozzolanic reaction to form calcium silicate hydrate (CSH) and calcium aluminate hydrate (CaH) as cementitious materials. So the factor affecting the soils are lime and wood ash content, curing time, curing temperature, and soil mineralogy. Soil chemical stabilizers have advantage and disadvantage. So its advantage are compress significant increased soil strength, reduce plasticity, so that it will increase the workability and increase soil durability. So that's all from us, group K9A. Thank you.